Hi everyone, welcome to VLSICareerCraft. Today let's solve an interview and log interview question that was asked by Texas Instruments, and the concept is on maximum power transfer theorem. Here, when we look into the question, here the load impedance is a reactive impedance, uh, which is having the resistive and the inductor, resistor and in the inductor. In a simple case where the load resistance is purely a resistive load, in that case for the maximum power to be transferred from the load to the source can happen ideally when the source resistance is 0 ohms. But here, since the load resistance or sorry load impedance is a reactive one, we need to solve this one with a slight tweak. Firstly, find out the V out equation at the with the output node. Okay, V out is equals to V in into Z load by ZS plus Z load, and P out is equals to V out square by Z load, and which is equals to V in square by ZS plus Z load whole square into Z load. This is this is the equation for the output power. So now we need to find out what is the impedance, ZS impedance, for the maximum power to be delivered to the load. So for that case, the denominator equation, let's take it as y, equation y is equals to ZS plus Z load whole square. Should be we should find out at what values of ZS this equation gives us a minimum value. Okay. Uh, we can do the dy by dzs and derive it, and we can find out the solution straightforward, but through the derivation. We can also solve this intuitively. First, let's see the intuitive way of solving this problem. Let us consider three cases where our ZS is purely resistive, and we consider the value of the ZS is equals to R. And the second case where ZS is equals to Z load. In third case where ZS is complex conjugate of output load impedance. Okay, let us derive the equation for P out for those cases. Let us see from here. V in square by modulus of ZS plus Z load, so Z load plus R whole square into Z load, which is equals to V in square into modulus of Z load by 2R square plus XL square. This is for the case 1, and for the case 2, ZL is equals ZX is equals to Z load. So for this case, our P out is straightforward answer, V in square by ZL plus Z load 2Z load modulus of 2 to Z load whole square into Z load, which is equals to V in square by 4 into Z load modulus. Okay, for the third case, where ZL is the complex conjugate of ZS is the complex conjugate of ZL, our equation for P out equals to V in square into Z load divided by modulus of R minus JXL, since it is complex conjugate of Z load, plus JXL whole square. It will cancel. Okay, the final equation for P out is equals to V in square by 2R square 4R square into Z load. Okay, if we look at the these three equations, equation 1, equation 2, equation 3, we can intuitively, or we can, it is evident that the maximum power gets delivered when the load impedance or the source impedance is the complex conjugate of the load impedance. Okay, and that is the answer. Yeah, till now we have seen the intuitive way of solving this maximum power transfer theorem question. As we mentioned earlier, we can also solve it using the simple mathematics as well. Let's do that quickly. Yeah, we took the equation y as zs plus zl whole square. If we do the simple derivation and equate it to 0, we'll get 2 into zl plus zs is equals to 0 and zl is equals to minus zs. So from this we can clearly say that the impedance of the reactive impedance of the load is the negative of xs, which we intuitively we find out that xs is the complex conjugate of xl. So we have verified this question in two methods, intuitively and the simple mathematics as well. In summary, if there is any question on the maximum power transfer theorem, if it is a purely resistive load, for the maximum power to be delivered to the load, or ideally if Zs is equals to a purely resistive one, if we consider it as a 0 ohms, the maximum power gets delivered to the load. If it is a reactive, if the question is involving the reactive impedance or something like that, in that case our source impedance should be the complex conjugate of the load impedance, or even the vice versa. Thank you. Thank you for watching. For more information or any suggestions, please let us know in the comments. And for more content for like this, please follow VLSICareerCraft channel. Thank you.